I'm at Flite Fest 2024, and this is the largest electric RC flying event in the country. And there's a whole lot of awesome giant foam airplanes out here, but not many giant foam helicopters. I want to change that.
Not only do I want to fly a giant helicopter here, I also want to put it through combat.
Oh, that was nuts.
For those of you who aren't familiar, at Flite Fest, they have what is probably the largest foam airplane combat battle in the world. Literally hundreds of airplanes take to the skies 3 times a day and battle it out to be the last one standing.
Now how nuts would it be if we put what's effectively just a giant 15-foot blender in the center of this chaos?
We don't have to imagine, since I spent the last 3 months designing, building, and testing this giant helicopter for the sole purpose of destroying it in the infamous Flite Fest aerial combat.
So if that sounds crazy, it's because it absolutely is. So in this video, I'm going to show you exactly how I pulled it off. Y'all ready? Yeah!
We're in 5, 4, 3, 2, 1, and launch.
All right, let's take off.
Giant RC helicopters are incredibly expensive and mechanically complex. Not exactly prime candidates for the kind of flying I want to do at Flite Fest with the budget I have. So to pull this project off, I'm going to need to dive into my old bag of tricks. A few years back, I built this spinning drone that uses wings on the arms to drastically increase hover efficiency, kind of like a helicopter if you squint hard enough. The idea wasn't all that new. Back in the day, engineers had this crazy idea to use jets on the tips of helicopter blades to propel the rotor, rather than a heavy engine and transmission system buried in the fuselage, and thus the tip jet helicopter was born. This idea is actually pretty smart because you no longer need a tail rotor to counter the reaction torque that a central engine and gearbox produces, making it more efficient. The reason tip jet helicopters never really gained popularity is because they were extremely loud, and it was really difficult to get fuel out from the non-spinning fuselage into the spinning rotor and out to the blade tips. This was less of a problem with my spinning drone. Electric propulsion drastically simplified the problem, and I was also able to use the fast reaction speed of the motors to pulse around the rotation and give responsive roll and pitch control. This got rid of the need for a complex swash plate assembly that could easily get damaged. This is the design I'm going to use for my giant RC combat helicopter, a huge tip prop-driven rotor with blades made out of hardware store wood and insulation foam. They'll be relatively easy to make and much more resilient to flying at Flite Fest among the swarms of smaller airplanes. In addition to those giant blades, I also need a de-spun platform in the center that can help show me which direction the front is while I fly it. So between the blades and the center hub, I have 2 huge sub-assemblies to get to work on with only 3 months left until Flite Fest. Let's get to work. Like all helicopter design engineers faced with the complex task of aircraft sizing, I headed out to my car to measure what the largest blades I could fit inside were, and that defined how big this thing would be. 6-foot long blades with a total rotor diameter of 15 feet to be exact. With that figured out, I headed out to the local helicopter supply store and grabbed some material to start making the blades. I used 1-inch thick pink insulation foam to serve as the backbone of the blade structure. I could have bought thicker foam and used a hot wire cutter to cut a proper airfoil shape, but we're on a tight timeline and budget. So instead, I'll be using what's known as a Klein-Fogelman or KF airfoil. This is effectively just a flat plate with additional material on the top and bottom, creating a distinctive step. The idea is that a small bubble of air circulates behind the step, making it kind of look like a regular airfoil to the rest of the air flowing around it. This creates quite a bit of drag, so this airfoil won't win any efficiency competitions, but it's darn simple to make, which is why I'm using it. Some 2-part epoxy helped laminate all the airfoil pieces together, and it came out pretty strong for such little effort. But to add some more strength and insurance, I used some foaming Gorilla Glue to attach a pine 1x2 just behind the airfoil step on the top surface. I also glued another wood spar to the other side of the blade, not really for any more bending strength, but because these 2 wood pieces will be the mounting point on the center hub, so they need to be really strong to tie all of the lift forces and moments from this huge blade into the rest of the vehicle. Of course, this blunt leading edge isn't the most aerodynamic, so I spent some time with a knife and hot wire cutter to add some bevel cuts. After that, all I needed to do was sand down my rough cut marks, and I was left with a nice looking KF airfoil. At this point, I couldn't help myself and decided to go pretend this was one of those giant cosplay swords in the backyard. It's actually pretty surprising how much lift this thing can generate at such low speeds. Anyways, we've got a blade, but we need a way to mount all the motors to it. I reached out to the sponsor of this video, PCBWay, and they offered to laser cut and bend 12 of these motor mounts for me out of 4mm aluminum sheets. I uploaded my file to their website and got an instant quote for free. After a quick review process, they were off to the fabrication shop and they arrived in the mail a few weeks later, all 12 of them plus spares. I'm told that this type of deep sheet metal bend is tricky to do, but from my perspective, this process was incredibly easy and PCBWay had no trouble making it happen. So big thanks to PCBWay for sponsoring this video and taking care of all these motor mounts for the build. Check out their website in the description for laser cutting, CNC machining, 3D printing, and of course PCB manufacturing services. I used my foam cutter to melt out some channels in the leading edge of the blade that the motor mounts could slot into with a bit of Gorilla Glue. The glue mostly filled the gaps and gave a really strong bond between the aluminum and foam blades. That was a lot of work to build the structure of one blade, so the only thing left to do was to do it all again. 3 more times. Definitely not questioning my sanity at this point in the build process. Next, I needed to focus on the center hub assembly. For this, I used some 1/4-inch plywood to basically make a 1-foot square cube. On the sides of the hub, I cut out some slots to align the blade grips, which are just some pine 1x3s cut to size. These will slot into the holes in the sides so they maintain the correct blade pitch angle and transfer all the blade loads into the center hub. As I installed the blade grips, I also used some 3D printed trusses to more securely tie them into the hub structure and to each other. The idea is that this is all fastened together with some drywall screws so I can take it all apart, transport it, and put it back together at Flite Fest. I'd say this assembly is more than strong enough for the forces of flight. Almost too strong. The hub build was easy. Now it's time for the harder part. De-spinning this center platform so I can tell what the front is while I fly it around. I cut out this circular piece of plywood and mounted up some 3D printed parts to it. The centerpiece will attach to a main drive shaft, and these little pieces are actually wheels. I'm basically just making a splintery Lazy Susan that'll sit on top of the center hub's lid. On the underside of the lid, I mounted up a gear motor, mount, and gear reduction assembly that I'll use to de-spin this platform while the rest of the vehicle spins underneath it. I wasn't really happy with the torque of this single little gear motor, so I used my big engineer brain to come up with a better solution that required the least amount of work. With the hardware taken care of, it's time to figure out how to actually control this whole thing. Let me temporarily mount some motors on this center hub and show you how this system works first. Slapping a couple gear motors on here didn't just magically and perfectly de-spin this platform for me. There's 2 key sensors and some flight control code keeping that top platform steady. I spent quite a bit of time thinking through how I wanted to achieve this. Here's a quick cutaway of that full system as it's mounted up on the center hub. This big part is rigidly mounted inside the hub and has a little magnetic encoder under the drive shaft interface bearing. There's a tiny diametrically polarized magnet glued to the main drive shaft that allows this encoder to accurately measure the relative position of the top platform. In addition to the encoder, there's a gyro to measure the absolute rotation rate of the whole vehicle. We'll call this omega gyro. If the whole vehicle, including the top platform, is spinning, then omega gyro will be some non-zero value, but the rate of change of the encoder measurement, omega encoder, will be 0 since they're both spinning together. If we want the top platform to not spin with the rest of the vehicle, then we need to spin the gear motor such that omega encoder is equal and opposite to omega gyro, canceling out the rotation. A simple proportional integral controller can look at these signals and generate a command signal to the gear motors to do just that. I can also input a desired angular rate difference, omega desired, to give me control over the direction that the de-spun platform is pointing, aka yaw control. All of this was implemented in my open source flight controller Dreamflight, and it was pretty straightforward to do with just a few lines of additional code. So we have yaw control now, but how do we actually control this thing in roll and pitch so we can move it around, or even just keep it from drifting in the wind? Using a few sines and cosines in the motor mixing, we can guarantee that no matter what the encoder position is, the motors will pulse around the rotation to create roll and pitch moments relative to the de-spun top platform. It's basically just a flying unit circle. If I hold a constant pitch input while it spins, you can actually hear the motors spooling up and down around the rotation thanks to this control output mapping. I went into much greater detail about this type of spinny control logic in my original spinning drone series, so be sure to go check those videos out for a deeper dive into how all this works. I basically just scaled all that up for this project. But now with only 1 month left until Flite Fest, it's time to finish up this build and do one final integration check before we head out. To wrap up with the blades, I soldered up all the speed controllers and then mounted the motors on the aluminum mounts. I'll get back to the details of this power system in a few minutes, but right now let's route all the wiring down each of these blades and tape everything down behind the KF airfoil. Surely these high power wires routed right next to the speed controller signal lines won't cause any interference. Excellent design decision, pass Nick. To power this monstrosity, I'm using not 1, but 2 of these 16,000 mAh 6-cell LiPo batteries I had laying around. I made this wiring harness to route power from these batteries inside the center hub out to each of the arms. Can't say I'm too proud of this one, but hey, it works. And just like that, every subassembly was done, so it was finally time to put it all together in the backyard for its first complete assembly. I used some clamps to pin all the blades on the blade grips, and then used a bunch of bolts and drywall screws to attach the blades for good, just like they do on real helicopters. Surprisingly, after powering up all the arms, every motor worked, and it was pretty sweet to see that center platform keeping the arrow so still. But some more spool-up tests revealed a terrible popping sound coming from all the motors, which was a bit concerning. I traced it back to interference from the brushed gear motors in the center hub, since the propulsion motors only stuttered like this when the gear motors were spinning the center section. So after I tore all this down, I added a few capacitors on them to filter out the noise spikes, and the problem went away, so I didn't think much of it. In hindsight, I probably should have investigated this interference problem a bit more, but I was running low on time before Flite Fest. At this point, the reality started to set in that I had just built a 15-foot helicopter in my basement, and that it's basically ready to fly. This thing had tons of power, and there was no doubt in my mind that it wouldn't be able to get off the launch stand. There's really nothing left to do before we take this up for its first flight, but there's no flying this thing in my backyard like my other projects. To fly it, we're going to have to take it all apart, pack it up in my car, and road trip out to Flite Fest in the great state of Ohio. We got there on Wednesday evening to set up camp, and we'd be leaving Sunday morning, so there were really only 3 days to get this thing reassembled and in the air for combat. My plan going into day 1 at Flite Fest was to get everything reassembled by the early afternoon and maybe get a quick test flight by the end of the day to verify everything works before we go for combat. The center hub went together with no issues, and then I got all the blades mounted. Under the main build tent where I set up shop, I wasn't the only person getting my flying contraption ready. Tons of people were working on their awesome builds preparing for combat, and plenty of people stopped by to check out what I was up to. It was great to meet so many of you who watch the channel, and I appreciate everyone that came to say hi and sign the giant helicopter. Early afternoon came, and I was ready to do a power-up test, but that's when things started going south.
I plugged the batteries in, and whatever happened caused this to fry. So I ripped this out of another airplane, and we're gonna solder this in, swap it in, emergency hack job, and see what works again.
I had no idea why powering up the vehicle caused my microcontroller to fry itself because I never had this issue back home. I spent an hour soldering up a new board thinking it was just an unlucky accident. No big deal. I hooked it up and powered everything one more time.
Can you point at it?
This one just fried it.
Turns out it wasn't just an unlucky accident, and I fried yet another microcontroller.
Gonna zoom in on that.
The cause was this servo lead out to one of the blades that was accidentally plugged in backwards, so whenever I powered up this one specific arm, the microcontroller just died.
That'll fry it. So, good news is, we know what caused this. This is not gonna happen again. Bad news is, I have to solder an entirely new TNC all over again. So let's do that. It's gotta go. We gotta get a new one.
By the time I wrapped up soldering the second new board, the day was coming to a close and I didn't feel like we needed to rush to fly that evening given all the unplanned stress getting it working again. So we decided to close up shop for the day and shoot for a test flight the next morning. By day 2, my buddy Michael was all set up next to me with a super cool FPV simulator chair.
Hey guys, I'm Michael Recton. I'm also here with Nick. I brought this chair that you can sit in and fly an RC plane. So if you sit in here, you've got your throttle, and you've got your joystick, which pitches and rolls you however the plane moves.
For some reason, Michael trusted me to take his airplane up for a spin, and it was awesome. I'll leave a link to his video on this project down in the description. The flight test team also made their way over in the morning, and I had some fun filming with Dave here. He's going to be tagging along for the first flight because Flight Test is actually going to be putting their own video out about this project, so keep a lookout for that on their channel.
All right, so before we take this thing out for a first flight, I kind of glossed over the power system during the build. Each one of these arms has 3 of these 730 kV motors and a 45 amp speed controller from Emax USA. They're spinning a 9x6 prop, and there's about 15 kilowatts of power on this thing in total. Emax actually reached out a couple months ago, and they basically said, hey, we love what you do, how can we help? So I pitched this project to them, and they basically sent the power system out the next day. So big thanks to Emax USA for literally powering this whole build. I'll link the exact motors and speed controllers I'm using down in the description.
The intent of this first flight was to get it in the air and see if I have any control over it before we ultimately destroy it in combat. I was extremely lucky to have all this help from the volunteers at the event and the flight test team who graciously shut down the entire flight line for us. After some pre-flight checks in the cornfield, we headed back in to observe from a safe distance, and all eyes at the event were on us. The only thing left to do was to throttle up and see what happens.
Moving first off.
Yeah.
All right, are we ready? It's going. You ready?
Moving, that's nice.
Good luck, buddy.
I'm gonna give it some juice, and we're gonna go take off.
Sure, you good?
I'm so scared.
You got this.
You guys, buddy. It's gonna do something.
Oh, that doesn't sound good.
Those motors don't sound happy.
Oh,
Ooh,
Those motors sound really, really unhappy.
that's not good. Okay, we might need to troubleshoot that.
So, remember when I said I should have troubleshooted the motor noise issues some more? Well, they were back, and this time it only seemed to happen past about 50% throttle, something I never got to test in my backyard. I know these motors had enough power to get in the air because they should have been putting out at least 60 pounds of thrust, with the helicopter only weighing about 40 pounds. I clearly wasn't getting full power.
Yeah, I don't want to kill the motors. I think let's power down everything. Let's go check it out and see if I see what fixes I can make and make this thing work.
With plenty of disappointment in the air, we made the walk of shame back into the build tent.
Didn't go quite as planned. I think there was some more motor interference issues, which I thought I squared away, but apparently not. What effectively happened was I was hitting about 50-60% throttle, and then that really awful noise started to happen from some of the motors. Not sure which ones yet, but it's basically some sort of interference to the control signal out to the speed controllers that's causing the motors to basically just turn on and off really fast. And that wasn't giving me all the power, so we didn't take off. So I'm gonna spend some time troubleshooting this, and we're gonna try and give it another shot later.
My buddy Peter shared some wisdom from the power systems on his past huge builds, and ultimately the solution we all came up with was to separate the wiring under the blades and shield them with some aluminum tape. As I implemented this fix, combat session after combat session passed by in the background while I started getting really worried that we were running out of time to fly. But by the end of the day, I was pretty confident the noise issues were gone for good, so we did a quick spool up test to full throttle under the build tent just to make sure.
So he was able to go full throttle, and there was no desyncing, nothing, sounded super smooth. So at this point in time, it looks like we're going to be able to actually put this thing in the air, which is super exciting because I don't think anybody knows what's going to happen when it's in the air, and that kind of just brings a whole lot of fun with it. So and we're excited about it. It's going to be awesome.
Everyone seemed to be confident we were ready to fly, but a storm started rolling in, so we decided to punt the real first flight to our last day at Flite Fest.
All right, so it's the next day. We spent quite a lot of yesterday troubleshooting after that failed first attempt. I got all of the wiring straightened out. We did a spin-up test. All the motors work. We get full power. Today we're gonna put it straight into combat. Last day here, we gotta do it. So I've added my little buddy here to go for a ride, and this is gonna be the ultimate combat target. So we're gonna lure the airplanes in and then hopefully suck them into the death blades. We'll see how it goes.
The team gathered to help move the circus out into the field all over again, while this time everyone else at the event started lining up for combat. It was all or nothing on the last day, so if this thing only managed to fly once, I wanted there to be carnage in the sky.
All right, so everybody's lined up for combat. We're gonna power this up, get all the cameras rolling, head back, and let the chaos ensue.
How are you feeling?
Really scared.
We made the walk back into the other combatants, and everything finally seemed to be in place for a successful flight. Stefan gave the go for everyone else to launch, and I followed shortly after. I'll shut up now and let you see what happened for yourself.
All right, arming.
And keep a head on the swivel, spotters. There's a lot of air flying now. Heads up! Oh my goodness.
That is absolutely insane. It's flying, kind of.
I have some control.
That is too cool, man. Great work.
Look at that thing.
I have some control.
Somebody go.
I have some control, not the most.
Oh my goodness, look at that. Yes!
Oh, wow.
Nicholas, I cannot believe this, man. You understand? Yes!
This is definitely an achievement for Flite Fest.
All right, I'm happy now. This is amazing.
Everybody go attack it. I need everybody to swarm the giant pinwheel
It won't
of
come back. No. Should I put it down?
You're
still safe right at the moment. There's gonna be a walk.
It's really far out there.
Oh, I think I got it.
Nobody's hurt.
Come back.
Nick, bring it home, buddy.
I'm trying so hard.
The wind is pushing.
There it goes. Oh no. Is it, Nick. Or is it no battery?
Down there, you might be able to
I don't know. Nicholas. Oh. Hey, that's a great landing. Well done. Hey, everybody back here, can I get a round of applause for Nick Rehm? What an amazing achievement. Well played, good sir. That is a huge success in my opinion. Unbelievable. You guys got it.
So we just took it up. It kind of like popped up with like 30-40% throttle, and it was just, whoa! That was nuts. The thing, it took off with like 30% throttle, just went up. There's a light breeze, so it kind of started getting taken away. I had a little bit of control, but the breeze was just taking it. So we drifted really far out there. I'm not sure if anybody hit us, but I think we had a soft landing, so we might be able to go again.
One thing about combat is that it's actually surprisingly hard to hit each other. As I drifted further and further away with the wind, it was even harder for the airplanes to venture out to hit me. Luckily, we did shred up a couple airplanes, but it wasn't clear how much damage I had sustained and if we'd be able to try for another flight. Once combat was over, we assembled a golf cart caravan and drove out into the cornfield.
All right, let's go check out the damage.
This is awesome.
Yeah.
Sorry, we got a lead foot driver.
You know I only got one speed.
We ended up drifting about a quarter mile away toward the edge of the field, and we needed to do a bit of off-roading. But when we got there, everything seemed to be completely fine.
Let's look at the damage, the devastating damage. Can we recover from this? I don't know.
So we loaded it up on the golf cart to bring it all back into the build tent.
All right, so the only damage was one broken prop. So I think it's safe to say we're gonna fly again. The guys are helping me out with the golf cart. Huge help. Thank you to all the Flite Test team and the people at Flite Fest that are, kind of just volunteering for this project. They're gonna take it back. We're gonna charge some batteries and we're gonna see if we can put this up one more time today. I'm so relieved that we don't have to go home without this thing having flown, because I did not want to take it home in the car again.
I couldn't believe we managed to fly at all given all the problems the past few days, but I wasn't gonna call the project done there. We need some destruction, so when the last combat of the day came around, we ventured back out into the field with some freshly charged batteries and a new prop. This would be our last chance to destroy this thing at Flite Fest.
Here in 5, 4, 3, 2, 1, and launch. Eyes open. Oh my goodness gracious. Hey, he's up. Heads up. Heads up behind. Flying out towards the corn. Flying out towards the corn. Flying out towards the corn. Hey, attack the spinner plane. Attack the spinner plane. Right now. Attack. Oh! I'm dead. I don't know where you're at, but you're not there.
I'm dead.
Holy cow. Oh my goodness. What a day. Oh, Peter, get in the air, buddy. Peter, someone's got to take Peter out.
Oh! Yes! That's it! That's it! Yes! That's it! Yes!
No way, Nick. You're not recovering from that one. Yeah! Fantastic. All right. Listen.
That was a solid hit.
It took a few attempts, but I think we finally gave this giant RC helicopter the combat send-off it deserved and the destruction I promised at the start of this video. Funnily enough, it looked like the same plane took both me and the helicopter out in 2 separate hits, but at least we chopped him in half too. I think the funniest part in this final blow is that one of the blades snapped in half, not lengthwise, but along the cord, severing the leading edge and motors clean off. Not the failure mode I expected in the slightest, but anything goes in Flite Fest combat. I knew we were totaled, but I didn't know how totaled, so we ventured back out into the corn one last time to assess the damage.
Let's go check it out. I don't actually know where it is. It's so broken. That is exactly what I wanted.
Did you get a hit? I found the person that hurt
Oh.
your plane. It's this guy.
Thank you,
You
sir.
find the guy that owns the tail. You found your.
I'm gonna go exchange some words with that nice fellow.
This one definitely wasn't like my usual projects, but I wanted to go big to celebrate and thank you all for helping the channel reach 100,000 subscribers. I appreciate all your support the past few years, and I hope you enjoyed watching me slowly lose my sanity trying to get this thing in the air. I also want to thank all the volunteers at the event, especially Carl and Merv, who were my right-hand men all weekend. I normally release free code or project files so you can build my projects yourself, but this one's a little big, so instead I'll be releasing the 3D print files for this little 1/10 scale model over on my website. Oh, by the way, I have a website now. I'll be posting more articles, tutorials, and projects over on dreamflite.com in the coming months, so keep checking in there for cool new stuff. That's all for this video. Thank you so much for watching and subscribing. Now I gotta go figure out what to do with these buckets of parts. Cheers.